Algebra 1, Lesson 53, Part A is about exponents again. In the beginning of your notes here are just reviewing a bunch of the rules and definitions we have already been studying. And this first one, we need to put a little brace right there. We have x being used as a factor m number of times here, and then the exponent is written like that. The rest of these, when you're multiplying them, you add the exponents, and a quick example with some numbers for the exponents will show why that is. X squared is x times x. If we multiply that times x to the third, that's a total of 5 x's being used as a factor, and so that you add. Some other definitions here. Cross the line to change the sign of the exponent. Anything to the 0 power is equal to 1. And then more recently we had the quotient rule, and that is where when you're dividing you subtract the exponents. Multiplying you add, dividing you subtract. Okay, the new one is this one, and above the box I think we will show why that is, because we'll do a couple of small examples, above it. We'll do some examples below it. So if we have a power raised to a power, and we're going to do one similar to in the box here, but with some numbers. So if we had, let's do x to the third squared. Okay, that means we're squaring x to the third. So that's x to the third times x to the third. But we already know when we're multiplying, and it's the same base, we add the exponents. Okay, your shortcut is, when it's a power raised to a power, you multiply those exponents. So x to the m raised to the power of n is just x to the whatever m times n is. Okay, so some quick examples down here. If we have a to the fourth to the 7th power, that's just a to the 28th power. Okay, if we have a to the fourth to the negative 7th power, that's a to the negative 28, which is also 1 over a to the 28. Alright, what if both of them are negative? A to the negative 4 to the negative 7. Well, when you multiply numbers that are the same sign, you get a positive result, so that's a to the 28th again. Okay, well, what if the inside one is negative and the outside? We'll do all the possible combinations. So what if we have this? Okay, still, when you multiply and they're opposite signs, you get a negative exponent. So that would still be that. All right. I guess that's enough there for now, and we've got some more examples on the back. Whoops, not the back, the next page. Here we go. So here we have, zoom that in a little. Okay, this whole thing to the third power. So, we were seeing if we just had one thing raised to the third power, we multiply the exponents. You can kind of think of it as distributing. Everything in there is being raised to the third power, because what this means is 2x to the 5th y squared z times 2x to the 5th y squared z times 2x to the 5th y squared z. Okay, that whole thing is used as a factor 3 times. But that means we have 2 times 2 times 2. So 2 to the third. X to the 5th is being used as a factor 3 times. So basically this is 2 to the third power times x to the 15th, because we multiply those, y to the 6th, because again we're multiplying the 2 times the 3, and z to the third. And then we must not leave, we must not leave the number to a power. We're going to simplify that. 2 times 2 times 2 is 8. So 8, x to the 15, y to the 6th, z to the third, and that one is done. Okay, one more in this section. We have here 3 to the negative 2 A, and then we do negative 2 times negative 2, that's a 4. And then our B, 5 times negative 2 is negative 10, over C, and this whole thing is in parentheses, this also is to the negative second power. So we have negative 8. And you never, ever, ever leave a negative exponent on a number. We have to simplify that. And the rest of it will depend on the instructions. If there are no instructions given, whether they want all variables in the numerator or denominator, I would make all the exponents positive. Okay, so a couple of these will move, and that 3 definitely has to move. We have a negative exponent on the 3, which means we have to cross that fraction bar. That makes it 3 squared in the denominator, but that's 9. A to the 4th, that exponent is positive. B to the negative 10, we're going to cross the line to change the sign of that exponent, and also the C. And there we are. That is the end of the Part A notes. Part B is shorter yet. This is more unit conversion. Just now, the units are cubed, so you'll need 3 of each unit multiplier. Okay? We're converting in this first one 44 cubic feet. That means feet times feet times feet. And I'm going to write it all 3 times because it's harder to miss all those feet than the little exponent. Okay, and I need every one of those feet to cancel. That's why we need 3 unit multipliers. Feet need to cancel. They were in the numerator. We put them in the denominator. And we're converting to cubic inches. So inches will be in the numerator. There are 12 inches in each foot. And so for this one, we have 44 times 12 cubed. The 12 is cubed, the 44 is not. The feet cancel with those feet, and we have inches cubed. That's it. Notice I did not put this over 1. If your entire denominator is just 1, please don't write it. Okay, in the next one, 6 unit multipliers. Okay, 1,800 cubic centimeters. So centimeters, centimeters, centimeters. Okay, I maybe should have written smaller. 1, 2, 3, 4, 5, 6. Okay, so we're going to cubic feet. So we'll do centimeters to inches, and then inches to feet. Okay, each inch is 2.54. I really squished that, sorry. Centimeters, and each foot is 12 inches. So we have, in the numerator, it's just 1,800 times a whole bunch of ones, so 1,800, and then in the denominator, because we're just multiplying straight across, 2.54 cubed times 12 cubed feet cubed. And that is the end of the notes. Have